Good morning, learners. Today, I want to take you through the solutions of analytical geometry test written on the 6th October 2025. So I just want to mediate the solutions. Now, without wasting time, let's go into it. Learners, when you answer not only geometry questions, it's very important for you to read the statement, because it's not always the case that they will give you uh, the it's not always the case that they will give you everything in the diagram. So read the statement so that you can close the gaps. Read the statement, just don't just look at the diagram. The first statement says in the diagram below, P, the coordinates of P minus 3 and 5, Q minus 6 and minus 1, R is 0 and P are the vertices of triangle PQR. Angle PQR is 90 degrees. ST are the x-intercepts of PQ and PR respectively. Now, let's look into this so that you can also see the diagram. Then you check the diagram. Now we are good to go, because if you check everything that is on the statement is also on the diagram. But note that it's not always the case that what will be on the statement will also be on the diagram. So here is your diagram. Let me enlarge it so that you see everything. Now, then from there you go to the questions. The first question says, determine, sorry, the gradient of PQ is, in a test, they'll just say determine the gradient of PQ. So you use the formula as you see. Then you'll say, let me make it bigger. Then you say the gradient of PQ is changing y over changing x. Then you substitute the value from the diagram. You'll see that the coordinates were given. Then you substitute, then you'll find the gradient as 2. 1.2, the length of PQ, using a distance formula, you'll get the answer as 3 root 5. 1.3, find the numerical value of P. Now let us, if you are given an unknown in a diagram, so if they are given unknown coordinate or unknown distance or whatever, first to check what you have. In this case, we are given that PQ is perpendicular to QR. So we know that if lines are perpendicular, or if the angle is 90 degrees, the lines forming that, the gradients of the lines forming that angle, their product is -1. So it means first gradient multiplied by the second gradient is -1. You know that. Then we know that the gradient of PQ is known, is 2. We calculated it in 1.1. Then you make the gradient of PQ the gradient of QR. Let me change it quickly. You'll make the gradient of QR to be -1/2. Now, then you substitute the values using the coordinates of Q and the coordinates of R. So we know that the y of R is P, then y of Q is -1, then x of R is P is 0, because it's the y-intercept. Then x of Q is -6, then which is equals to -1/2. Then you make P the subject of the formula. Then P will be -4. 1.4, determine the coordinates of S, or the coordinates of S are. Now, if you look at this, the coordinates of S in this case, uh, we say PQ, the gradient of PQ and the gradient of SQ is 2 because both PQ and R are collinear. They're on the same straight line. Now, therefore, uh, you use the gradient of SQ, but the gradient of SQ, you know it is 2. We calculated in number 1 as the gradient of PQ, but PQ and R are collinear. Then if the points are collinear, the gradient of any 2 points is the same. So then we know that x of Q is -1, x of S is 0 because y of Q is -1, y of S is 0 because that is the x-intercept. Then x of Q is -6, x of S is unknown. Then you cross multiply, then you make x of S the subject of the formula, which is -11/2. Then S is in -11/2, 0, or -5.5, or -5.5 and 0. So it means in this case your correct option would be a C. Now 1.5, the length of PS. The length of PS. Now if you check, the length of PS would be the x of P minus the x of S, which we calculated in 1.4, plus y of P, which is 5, then y of S will be 0 because it's the x-intercept. Then you'll get the answer as 5√5/2. Now, 1.6, the equation of PR is, now, the equation of line PR, first we'll calculate the gradient of PR, then you'll say is y of P minus y of R over x of P minus x of R. Y of P is 5, y of R is -4. We calculated it, and then and then x of P is -3, x of R is 0, S is the y-intercept, then equals to -3. Then you substitute in the equation of y is equals to mx plus c to get that. Or we know that y-intercept is always the value of c. So if you check r is the y-intercept, then c is -4. Then you'll have y equals to -3x minus 4. So then the equation would be -3x minus 4. 1.7, the coordinates of TR. Remember, T is the x-intercept of line PR. We have just calculated the equation of line PR, which is y equals to -3x minus 4. Now, at t, we know that y is 0. Then you let y to be 0 because t is the x-intercept. Then you substitute y as 0. Then you make x the subject of the formula, which it will be -4/3. Therefore, the coordinates of t is equals to -4/3 is to 0. 1.8, the size of angle PST. Remember, PST is the angle of inclination of line PQ. We know the gradient of PQ, which is 2. We calculated in 1.1. Then you say tan PST. S is the angle of inclination of PQ. You say tan PST equals to the gradient of PQ, which is equals to 2. Then you say shift tan 2. Then you get 63,43. is remember PST is the angle of inclination, then the answer is 63,43 degrees. Number 9, if it is further given that QR is 3 root 5, the area of quadrilateral QSTR is. Let me quickly go back and then come and check this. I'll just copy this and take it there so that we talk about something that we see. So we are required to calculate the area of QSRT, QS or QSTR. So I think let's check, QSTR, yes, QSTR. Now, if you look at QSTR, it's a quadrilateral, but it's an irregular one. So there's no formula that you can use to get this. But we see that we can calculate the area of this using the area rule, because if you know the coordinates of S and T, we can calculate the length of ST. Already we know the length of QS, and already we calculated this angle. It means for this one, you can use the area rule. And then the bigger triangle, we can use half base times height. So since we don't have a formula to calculate QSTR, then we'll calculate the area of the whole triangle and the area of this one using the area rule. Then you say the area of the bigger triangle minus the area of the top one, then the answer will be QSTR, because it's an irregular polygon. So since we calculated the angle of inclination, first we'll say the area of triangle PQR, which is the bigger triangle, we say PQR, is half base times height, because PQ is perpendicular to QR. So it means we'll say half PQ times QR. So because we are further given that QR is 3 root 5, then you'll say is half times 3 root 5 times 3 root 5, then the answer will be 22, the answer will be 22,5. The answer will be 22,5 square units. So now, as we already know the length of PS, which we calculated here. Where did you calculate PS? We know the okay. Let's just quickly go here. Let's check. Now, let's check the length of ST is remember when you calculate the horizontal distance, is the bigger value minus the smaller value. So we say it will be the x coordinate of t minus the x coordinate of s. And I remember we already calculated the length of the small t is the PS. Let's see where we calculated PS. I remember we calculated PS somewhere here. We calculated PS and we found that it's 5 root 5 over 2. Remember when you use the trig rules, small letter t will be PS, small letter t will be PS, and small letter p will be ST. That is why we got ST, because it's a horizontal distance. It will be the length of S, sorry, the X value of S minus the X value of S. Sorry, the X value of T minus the X value of S, because it's the horizontal distance. We know that even if you can use the distance y, it will be fine, but we know that for y would be is 0 minus 0. So there's no need to go that route. So the small letter t, the small letter p will be the length of ST we calculated here, and then the length of the small letter t is this side, which is the length of PS, which we calculated in one of the questions as 5 root 5 over 2. Then times sine the angle here. The angle would be S. We know the area rule. So now when you calculate the area of triangle PST by using the area rule, then you get is 10,42 square units. So it means the area of this irregular polygon, which is QSTR, it will be the area of triangle PQR, which is the bigger one, minus the area of the triangle PST, which we calculated by using the area rule. Then the answer will be the area of QSTR. So that's the area. Then the answer will be 12,08. Now, 1.10, if PQWR is a parallelogram, the coordinates of WR. Now let us, if they say they give you a letter that was not initially given on the diagram to say P, just follow the order. If they say PQWR, you look at the order here. We talk about PQWR. P is up there, Q is here, it means W will be here. But if we're saying PWQR, it means W will be here. If we say PWQR, but here we say PQWR. The order is very important. It means W will be here because it's PQWR. It means it will be in the third quadrant. Then it means now we know that it is this side. So you know how to calculate the coordinates if they say that this is a parallelogram. First, you find the midpoint of QR. SQR would be the diagonal of PQWR. So you find the midpoint of QR. Then from there, you say the midpoint of PW will be the same as the one of the QR because the diagonals of a parallelogram bisect each other. Let me make it smaller so that you can see every part of it on a diagram. Since we say PQWR, it means now PQR will be the diagonal of that of the parallelogram, then PW is the other diagonal. So that is why we know that if you find unknown vertex in a parallelogram, you first find the midpoint of the diagonal that has both the coordinates. So you'll find the coordinates of the midpoint of the diagonal QR. Then you'll say that the midpoint of diagonal PW is the same as the one of QR. So the midpoint of diagonal QR, we found that is minus 3 is to minus 5 over 2. Then from there you separate the two because now in PW, first we'll say the midpoint of QR, you substitute, you get negative 3 and negative 5 over 2. Then after that you say the midpoint of QR is equal to the midpoint of is the midpoint of QR is equal to the midpoint of PW, which is the same as minus 3 as minus 5 over 2. Your reason is that diagonals bisect each other. So therefore it means the the x midpoint of QR is minus 3, then x midpoint is x of p plus x of w over 2, then x of p is known, is minus 3, x of w then over 2 is equals to minus 3, then you cross multiply to get minus 6, then you take minus 3 to the other side. The other side will be plus, it will be minus 6 plus 3, then which is minus 3. Same story with y. We know that the midpoint of diagonal PW is minus 3 and minus 5 over 2. It means the midpoint is minus 5 over 2. X of p, we know it as 5. Y of w, sorry, y of p is known as 5. Then y of w is unknown. You cross multiply. Then minus 5 over 2 times 2 is minus 5. Then when you take the 5 to the other side, it will be minus 10. Then it means the coordinates of w are minus 3 and minus 10. Now, we go to number 2. In number 2, you were given the statement in the diagram below PQR with T, which is M and N, on QR. R is the y-intercept of QR and PR respective. Sorry, y-intercept of R is the y-intercept of QR and PR. You can see then R is this. Let me put it nicely. R is the y-intercept of PR and QR, as the statement says. And the PQR is beta, or PQR. We no longer have PQR as the beta. Now, let's cancel this. Okay, let's just cancel this one. There's no beta here. Now, QR. QR is parallel to PS. You can see that it's marked with the arrows on the diagram. This one is fine. PTQ is theta. PTQ is theta, as you can see. And then RPS is alpha. You see that RPS is alpha, is shown there. And and then QT is equals to TR. You see that. And then VW and Z are the x-intercept of PQ, PT, and QR. These are the x-intercept, and you can see that. The first question, the equation of QR is, now if you check in this one, QR, you only know one point, but you don't know the other point. So you can't go straight here and calculate the equation, the gradient. So if you are given a line which the information which is not sufficient, it means that there's somewhere where you can get your gradient. Now, like here, you see that you are given that these two lines were parallel, and we know that when the lines are parallel, gradients are equal. So we'll say, oh, because PS has enough information, let me use PS to get the gradient. And then once I got the gradient with this line that has enough information, then we say the gradients are equal. Because it was impossible to go straight here and find the equation. Now, you see the first question, then you find the gradient of PS because PS has enough information, and then you see that y2 is 2, y1 is 1, x2 is -1, x1 is 0. That is why you got that. Then you say 2 minus 1 minus 1, then you get the gradient of PS, which is the same as the gradient of QR, because the lines are parallel. So it was impossible to go straight and get the equation of QR because QR didn't have enough information. But looking at the property that if lines are parallel, gradients are equal, then you say, oh, QR is parallel to PS and PS has enough information. Let me use PS to get the gradient. After that, you say, therefore, the gradients are equal. Then the gradient of PS is -1. It means the gradient of QR is also -1. Then you substitute. Then you go to QR. Since you know the coordinates of Q, you can substitute to mx plus c to get the value of c. Now, gradient of QR, which is the same as the one of PS, then is -1. Then you substitute -1 on the gradient. Then from QR, x is -4. X1, y is -1. Then where there's x, you put -4. When you try, you put -1. Then you get c. Then the equation of QR is negative x minus 5. Now, determine the numerical values of m and n. If we go back and look into this diagram, we were given that t. Remember, m and n are the coordinates of t. T is the midpoint. If t is the midpoint, it means you must use the midpoint formula to get it. But we don't know the coordinates of r. Then we say, since we calculated the equation of QR, then to get r, you say r is the y-intercept. R is the y-intercept. Then you let r to be, you let r, so you let y to be 0. Sorry, you let x to be 0 because r is the y-intercept. You let x to be 0 because you know the equation of QR. Then the answer will be -5. Then the coordinates of r will be 0 and -5. Then obviously to get the coordinates of t, then you use the midpoint formula. Then you say, is the y or the x of q minus x of r. X of q, remember, is -4. X of r is 0 because it's the y-intercept, over 2. Then the x of q is -1. And then the x of r, which we have just calculated, so the y of q is -1. Then the y of r is -5, which we have just calculated here. Then the answer will be -2 is to -3. Then it means m is -2 as it is x. Then n is -3 as it is y. As it is y. 2.3, the size of theta is. Now let's look into this diagram. You can see that theta is not the y-intercept. So the theta is not the angle of inclination. Theta is not the angle of inclination. And we can't use exterior angle of a triangle is equals to the interior opposite angle, because this theta is in a quadrilateral, not in a triangle. Since it's not in a quadrilateral, you can't easily use the angles of inclination because it's not in a triangle. Now, but we know the coordinates of the coordinates of triangle, the vertices. You know the coordinates of triangle PQPTR. We already calculated the coordinates of T and the one of R. We can use the cosine rule because the distance can be calculated. Here we can't use the angles of inclination because this theta is not in a triangle, but you can use the cosine rule. We know that for cosine rule you use it if you know the length of the distances. So you know the distance of PT, we can know the distance of PR, we can know the distance of TR because these are the coordinates. Now then let me just copy and put it so that when as you are doing this you'll see what we are talking about. Let me just copy and paste it here so that we work with something that we see. Now you'll see that here, let me make it a bit bigger. You'll use distance formula first to calculate the length of PT because we know the coordinates of P, which is -1 and 2, and then the coordinates of T. We know the coordinates of P, which is -1 and 2, and the coordinates of T, which is -2 and -3. We just calculated that. Then you use a distance formula to calculate them. As you see, we use the distance formula because x of t is -1, y of x of p is -1, x of t is -2, which we calculated in 2.2. Then y of p is 2, then y of t is -3, which we calculated in 2.2. The answer will be root 26. The answer will be root 26. Then you calculate the coordinates of t. Sorry, we find the length of TR. TR is this side. Then we use the coordinates -2 and -3, and also 0 and -5. We know that x of t is -2, x of r is 0 because it's the y-intercept. Y of t is -3, we calculated in 2.2, y of r is -5. Then you square that, and then you will have tr as 2√2. Then PR, same story. Distance formula, we know the coordinates of t, p, and the coordinates of r. Then x of p is -1, you see that. X of r is 0 because it's the y-intercept. Y of p is 2, you see that. Y of r is -5, s is the y-intercept, we calculated it. And then you get answer as 5√2. Now, then you can use the cosine rule. Cosine rule is, we know that because we are calculating theta, which is angle PTR. So we'll say cos t equals to p squared plus r squared minus t squared. You remember that with cosine rule, if we started with cos, where the angle is t, it means the small letter t will be at the end and will be subtracted. So it will be cos t. If you do as cos p, it means p squared will be at the end. You know the cosine rule. So because we are calculating cos t, then t squared will be at the end as negative. Now, then we say is equals to p squared plus r squared minus t squared over 2pr. Then if you also use it as t squared equals to p squared plus r squared minus 2pr cos t, and then made the after that you substitute as it was, make and manipulate to get the answer, is still fine. It will still be fine. So then you substitute, then you say shift cos the answer you got here. Then you get the answer as one. But if you calculate this one first, don't round it off. You say you get the answer, then you say shift cos, then the answer will be 123,69. We use cosine rule. So you must also be aware that there are questions where you'll be forced to use the cosine rule. But if, let's say theta was here, we'll use the inclinations. You'll find the inclination of PR, you'll find the inclination of PT, then you say exterior angle is equal to the sum of two opposite interior angles. But in this case you can't, because this theta is in a quadrilateral here. So you can't use the exterior angle is equal to the sum of two opposite interior angles. But if there was a circle, you use then you'll say exterior angle of a cyclic quad is equal to the interior opposite angle, but here we don't have a circle. So the only way to get the angle was use the cosine rule. But with the cosine rule, you need to know coordinates of all the vertices of that triangle. Use the distance formula to calculate the distances of all the sides of a triangle. Then you apply the cosine rule. Now the next one is saying the size of alpha is. You know that alpha in this case, if we knew this one, it could have been easy to say these are the co-interior angles, but we don't know this angle. You can't use the co-interior angles. But we know that alpha equals to PRT, which is this angle, because they are alternating. Now, since we know this angle, then we use the sine rule to get this angle. You say, because you want this angle, you say sine of R is equals to sine of R over PT is equals to sine of theta, which we know as 123,69 over PR. You know how to apply sine rule. That is why sine of PT, sine of R, which is this angle, equals to the length of PT, which is root 26, is equals to sine of 123,69, which we calculated in 2.3 over PR, and PR is 5 root 2. Then you get the answer, then you say shift sign, then you get the answer, which is 36,87. Therefore, you say alpha will be PTR, which is equals to 36,87, reason alternating angles equal, PS parallel to QR. Done with number 2. Then we go to number 3. Number 3, you say you are given the equation of the two circles. The first equation has the center M. The first circle has center M. The second one has center N. Which one of the following is the correct about the two circles? Are the two circles intersecting once, twice, they don't intersect, or the center of one of the circles lies on the circumference of the other circle? First, let's look at this to see if they intersect or not. Now, first we find you complete the square to determine. Let's do this so that it will be nice. Let's move this one here. Just want this. Now you see, you complete the square here, say plus 10 over 2 all squared. Here you say plus minus 6 here over 2 squared. But remember, whatever you do on the left, you also do it on the right. So obviously 25 will go this side, will be negative. So what you did here, because it was not there, you repeat on the other side. Then you also repeat this on the other side. Then this will be 10 over 2 is 5. Remember, when you come to this, you don't even now look at this. You just say 10 over 2 is 5. Then you put 5 here, all squared. Minus 6 over 2 is minus 3. Put minus 3, all squared. Then here it will minus 25 plus 25 plus 9. So, and then it will be 9. Then it means the center of the first circle is negative 5 and 3. And the radius will be the square root of 9, which is 3. You complete the square in the other one. First, you take 11 to the other side. Say 4 over 2 all squared. Here you say 2 over 2 all squared. What do you do on the left? You also do it on the right. Then you don't, from there, you don't even look at this one. Here it will be 2. Then 2 squared. So 4 over 2 is a 2. Then it's a 2 here. 2 over 2. 2 over 2 here. It will be positive 1. Then here it will be 11 plus 2 squared, which is 4, plus 1 squared, which is 1. 11 plus 4 plus 1 is 16. Then you say the center of the first circle, of the second circle is negative 2 and negative 1. And then the radius is the square root of 16, which is 4. Now, by me looking, let's look at whether the circles intersect once or twice, they don't intersect, and all that. If one of them does not hold, then we'll see if the the option C will hold. Because now, if if the center of one circle is on the circumference of the other, it means when you calculated the radius of the distance from the center of one circle to that that of the other will be equals the radius of the other. But here, let's first check this one, whether the circles intersect. First, you calculate the distance between their centers using a distance formula. So we know that the centers, x here is minus 5, then x here is minus 2. Then you substitute. Y here is 3, y here is negative 1. Now, in other words, now we are calculating the distances between the centers. The distance between the centers will be 5. Now, so let's look at the sum of the radii. Radius of one circle is 3, radius of the other is 4, then it's 7. But if you see, the length of mn, which is the distance between the centers, is less than r1 plus r2, then we know that if this is the case, it means the circles intersect twice. If they were equal, it will mean that the circle intersect once. If the distance between the centers is greater than r1 plus r2, it means the circles don't intersect. But in this case, because mn is less than r1 plus r2, then we know that we'll say that then the circles intersect twice. It means the correct answer will be A, D. The circles intersect twice because the distance between the centers, or the length between the centers, is less than the sum of the length of the radii 1 and 2. Radius 1 and the radius 2. Now, the answer is a D in this case. 3.2. If it is further given that, there is point P with coordinate minus 4 and 1, which statement is correct about P? P lies outside the circle. P lies, first one say P lies outside both the circles. The second one, P lies outside circle M and inside circle N. P lies outside circle N and circle M. P lies inside both the circles. Remember, when you determine whether the point lies inside or outside, you'll calculate the distance between the center and that given point. If that answer is less than the radius, it lies inside. If the answer is equal to the radius, it lies on the circumference. If the answer is greater than the radius, it lies outside. So let's calculate the distance PM. PM is the distance from the center of circle M to P. Then we substituted, we got the answer as root 5, which is the same as 2.24. Now, we also calculate the distance between P and N, which is the center of the other circle. We found the answer is 2 root 2, which is the 2,83. But if we check, R1 is 3, then R2 is 4. It means both the distance between PM is less than the radius of circle M. Also, the distance of PN is less than the radius of circle N, because the radius of this one is 4, the radius of this one is 3. It means P lies inside the circles with center N, and also P lies inside the circle with center M, because in both the cases the distance between the center and P is less than the radius. So therefore the correct answer in this case, it will be D. It means P lies inside both the circles, because the distance between the center and the center of both the circles and P is less than the radii. So because the radius of P of M of circle M is 3, and then 2,24 is less than 3. The radius of the circle with center N is 16. So 4, which is the square root of 16. Then 2,83 is less than 4. It means P lies inside both the circles. 3.3. Which of the following are the equations of the tangents? The equation of the tangents of circle M, which are parallel to the y-axis. So we know that the lines which are parallel to the y-axis, it means they are perpendicular to the x-axis. It means the x does not change. It means x is the same everywhere. Now, we know that the circle center M, the radius is 3. So, and then the center is -3 and 5. So it means the tangents will be vertical. Then to get the tangent, it means to get the left tangent, you say -5, -3, because when you count to the left, then you say that it will be minus, because the radius is 3. Then you say -5, -3. Then the equation of the vertical tangent of the circle M on the left, it would be x equals to -8. When you get the one on the right, you'll say -5 plus 3, because the radii of the same circle are equal. It will be -5 plus 3. Then it will be x equals to -2. It means the equation of the equation of the vertical tangent of the left side of the circle M, it will be x equals to -8, and then the equation of the tangent or the vertical tangent of the on the right of the circle M, it will be x equals to -2. It means the answer here, when we simplify that, the answer here, it will be x equals to -8, and the other one will be x equals to -2, meaning if you are calculating the vertical tangents or the horizontal tangents, you use the radius. If you have for vertical tangents, use the radius and the x value of the center. Then the horizontal, use the y and the radius of the circle. So here the answer will be this. These are the equations of the vertical tangents of remember, we say vertical because we said those tangents are parallel to the y-axis. It means they are vertical. Then it means in this case the correct answer will be D. Which of the following are the equations of the tangents of the circle, the tangents of the circle which are parallel to the x-axis? We know that anything that is parallel to the x-axis is horizontal. It means it's horizontal, and if it's horizontal, y does not change. So we say, for circle N, the radius is 4, the the center is -2 and -1. Because we want the horizontal tangent, we will use the y value and the radius. We know that below, when you count downwards, we'll say negative. It will be, since radius is 4, for the tangent below, you'll say -1, which is the y value of the center, minus the radius, which is -4. Then it will be -5. Above the center, you'll say -1 plus 4, which is 3. Therefore, these are the equations of the horizontal tangents of circle N. These are the equations of the horizontal tangents of circle N. These are the equations of the horizontal tangents of circle N. Okay. Now these are the answers. Means the correct option in this case will be B. Then y will be -5, or y will be 3. Now 3.5. Line y equals to x plus 5 is to the circle with center N. So here we want to determine whether line y will be the secant to the circle N, the tangent to the circle N, the radius to the circle N, or the diameter to the circle N. Now, if you substitute this line to the circle, remember x is x plus 5, where this y is x plus 5. It means where you see y, you put x plus 5. Then when you simplify, you'll get this. Now, here you get 2x values. The 2x values means that the circle, it means that the line touches the circle twice. If the line touches the circle twice, it will simply mean, if the circle touches, if we have 2x values, it means the circle the line touches the circle twice. And then for that reason, we will say it is a secant because it touches the circle twice. It is a secant because it touches the circle twice. But remember, the diameter touches the circle twice, but there's no there's no there's nothing which shows that this line subtend the angle at 90 degrees. The subtend the angle of 90 degrees. So there's nothing that will give out all the reasons of saying that is a diameter. But we have all the reasons of saying it's a secant because the secant touches the circle twice. So remember, the secant has nothing to do with the center. The secant has nothing whatsoever to do with the center. As long as it touches the circle twice, then it's a secant. So the answer is A. But if we got only one x value, we'll say it's a tangent because the tangent touches the circle only once. Then it's a secant because we have two x values. Obviously, if you have two x values, you'll get two y values. Now, in the diagram below, now we go to number 4. M is the center of the circle. Chord KL is perpendicular to MN. Let me make it bigger so that every one of you can see it. Now you can see that KL is a chord. It was given that is perpendicular to MN, and we were also given that MN is parallel to the y-axis. These are the coordinates. Then KM is √3, and then N doesn't. The coordinates of N are known. The coordinates of L are -1 and -7. All these are given on the statement. First thing, what are you going to say? We know that if KN, if a line from the center is perpendicular to the chord, then that line bisects the chord. So first we'll say, because we are given, this is the converse of grade 11 theorem. So you'll say, therefore, M. So first we'll say N is the midpoint. It is the midpoint because converse of grade 11 theorem, it states clear that if a perpendicular line is drawn from the center to the chord, it bisects the chord. But when you give the reason, just say perpendicular from center to chord, then it means N is the midpoint. Since we know the coordinates of K and L, so it means x of K, we know that is -1. Oh, we can just say, let's just check here. We see that x of L is -1 and x of K is -5. Okay, y of K is -7, and also y of L is also -7. When you divide them, the answer, the coordinates of the center would be -3 and -7. So it means we applied the converse of theorem 1 of grade 11 to say if a line is drawn from the center to the chord is perpendicular to the chord, it means that line bisects the chord. So you just say perpendicular from center to chord. Now from there we calculate Kn using a distance formula. If you want Kn, we'll say Kn, let's just here, we say Kn, since we know the coordinates of N, we say Kn -5 is the x value of K. Then the x value of N, we calculated it here to be -3, we can say -3 all squared. The y of K is -7, y of N is -7. Then the answer in this case, it will be a 2. Kn is 2. Then You use the Pythagoras because they are perpendicular, since Kn is 2 and then Km is root 13. You can get the Mn by using Pythagoras. Then the answer of Mn would be 3 units. So now we know that if the line is parallel to the y-axis, x is the same everywhere. It means now, since x of n is minus 3, it means x of m is also minus 3, because when the line is parallel to the y-axis, x does not change. X does not change. X does not change. That's why we say the x coordinate. That's why we say the x coordinate of m is -3. Then from there we go on and say, since the y of n is -7, it means for vertical distance now, it means the y of n will be -7 plus 3, because the length of mn is 3. It means the y of m will be -4. Therefore, the coordinates of m are -3 is 2, or -3 and -4. That's the answer of number 4. Then it means the coordinates of m it means the coordinates of m are -3 and -4. Number 5, in the diagram below the circle, let me just take it to the diagram to the other page, make it bigger, so that we interpret what we see. And then let's quickly go to the next page. Let's say now, let's put it here. Let me put it here so that when we read the statement, we say, let's read the statement. In the diagram below, the center of the smaller circle is 1:-2. You see, this is 1:-2. Let me just put it so that we see every part of it. Now, the center of the larger circle is N, which is A and B. You can see that is N, which is A and B there. So that is why I'm saying it's important for you to read the statement. The center of the large, we did that. The equation of the common tangent is tangent PQ to the circle at R is, remember R is 0 and -1, is y equals to x minus 1. Let's see whether you have that. You see R is here. The equation of the tangent is given. Now, the two circles intersect once, and the radius of the circle N is twice the radius of circle M. So now the question says find the values of A and B are. Now let me just bring this to your attention. If you are given unknown, especially when you are given two unknowns, so obviously you know that you'll use a simultaneous equation in most cases. And then for you to know how your simultaneous equation will look like, you will check what you know. Like you're given that the radius of this is twice of this. We know that we can get this radius using a distance formula. It means now we can use distance formula because the distance will be known. And then we come again to say this will be equation 1. The other equation, where we look at other equation, we'll say, oh, since we are given the equation of the tangent, it means you know the gradient of this tangent. And if we know the gradient of the tangent, we will know the gradient of the radius. Remember, N, R, and M arc will be collinear because the circles intersect twice. And then remember, R is at that point of contact or the point of intersection. So it means N, R, and M, they are collinear. That's on the same straight line. Therefore, it means the gradient will be the same. It means we are going to form equation 1 by using the distance formula because we can determine the distance. We use the equation 2 by using the gradient formula because we can determine the gradient of Mn. The reason being that M, N, and R are collinear. Now, first, since we say the gradient of the radius of NR is twice the radius of MR, I think it's given in the statement. We say the gradient, where are we? We say the two circles intersect and the radius of the circle N is twice the radius of circle M. So it simply means that the radius MR or the NR is 2 times MR. So we first find the radius of this. We'll say radius, we are going to use the distance formula. We say 0 minus 1 squared minus 1 minus 2 squared. That is what we did here. Or first, we said we say since we know the gradient of the tangent, which is 1. We say the gradient of Mn times the gradient of PQ is minus 1 because radius, your reason is that radius is perpendicular to the tangent. Is that radius is perpendicular to the tangent, radius perpendicular to tan. So it means the gradient of Mn will be -1. That is why you make equation by use the gradient formula, because we know its gradient. We know the gradient. So we say B, which is y of n minus y of n. And then remember, y of n here we know it. Y of n is -2. X of n is a, x of n is -1. Hence we said b minus 2 over a minus 1, which is the gradient formula. Then we say equals to -1. Then you cross multiply. A minus 1 times minus 1 will be minus a plus 1. Then you take 2 to the other side. Then it will be 1 minus 2, which is -1. Now, then this is equation 1. Equation 2, we are going to create it by using the distances, because we're given that the radius of circle n is 2 times the radius of circle 1. So you say R1, which is the radius 1, substitute, you get the answer. The answer will be √2. It means the length of Mn will be 2 times √2 plus √2. Remember the let me put this way. Remember we said this one is 2 times this one is 2 times this one. This is √2. Then from here to here it means it will be 2 √2. So but it means the whole length will be 2 √2, which is NR, plus √2. Then that is why we have √3. That is why I have root 3. 3 root 2. No, sorry. It have 3 root 2. Now, then we use the distance formula, because in this case, distance, we know it. Then we'll say the distance of mn is the x of m, which of n, which is a, then x of m is minus 1. Y of m of n is b, y of m is negative 2. But that distance, we know it is 3 root 2. Then you also square it. Then from there, you simplify. Then you have equation 1 and equation 2. Then you substitute 1 into 2. It means now, remember in equation 1 we found b as minus a minus 1. It means where we see b, we put minus a minus 1. Then here we'll have plus 1. You clear the brackets. When you write this in a simplest form, in a standard form, then you'll have a squared minus 2a minus 8 equals to 0. Then you factorize, then you get the answer. But we know that at n, x cannot be positive, then it means a will be negative 2. Now to get b, you'll say you substitute one of the equations, preferably the simplest one. Remember, in equation 1, we determined b as minus a minus 1. Then where there's a, you put minus 2. Then answer will be positive 1. Then this will be the coordinate. So just know that if you are given unknowns where you have two equations, you check the two things that you may know. Here, the two things that you know is the gradient and the distance. If we know the midpoint, you'll use the midpoint formula and something else. So, but here we know the distance, and you also know the gradient. So that is why you created equation 1 by using the gradient, then equation 2 by using the length or the distances. Number 6. Let me put this on the other page so that we can see it clearly. Number 6. Let me cut this part so that we can make this one bigger. All right. This is the diagram as a statement says. Let me just put the diagram nicely so that we can see. Let's read the statement to see that whatever we have is on the statement. The statement says, in the diagram, the equation of the circle M is the circle with center M. You see that the center there is M. Now, we say we are given the equation, and the equation of the tangent of the circle at C, which is P and Q, is y equals to x plus k. The length of OA is 7 units. The length of A is 7 units. But we know that it's going to the left. It means the coordinates of A will be minus 7 and 0. Let's look in the first question. Determine the coordinates of the center of the circle and the radius. Completing the square as we did with the previous questions. Let's make it nice here. Now, you complete the square here. You see, as you complete the square, first you say, we already completed the square already. Here you say 2 over 2. Then what you do on the left, you do on the right. You say minus 4 over 2 squared. What you do on the left, you also do on the right. So you took 3 to the other side because it was minus 3 on the left. When you take it to the other side, it will be positive. So the answer there would be 8. And but we know that radius will be the square root of the answer you get here. The square root of 8 is 2 root 2. Then the center will be -1 and +2. You can see that the center will be -1 and +2. Now that's the center and the radius of the circle. The second question, the length of AC is. Let's check what AC, where the AC is. AC. Now, you can't go straight here because yes, you'll know the coordinates of A as -7 and 0 because the length of OA is 7 units. It was given on the statement. But you can't go straight here because you don't know the coordinates of C. But we know the coordinates of M, which is the center. We know the coordinates of A. We know the length of the radius, which is √8 or 2 root 2. So then we can start by calculating the length of MA because MA has enough information. We know the length of this, then you use Pythagoras because radius is perpendicular to the tangent and it will make this to be a right angle triangle. Let's start. As the starting point, we'll find the length of OA, it's AM, because AM have both the coordinates, which is the center and the and A. The x of the center is -1, x of A is -7. You see -7 squared. Then here we'll say x of the center, y of the center is 2, y of A is 0. So you say -0, then answer will be 2 root 10. The radius we know, we calculated it. Then the radius we calculated it as 2 root 2 or √8. We calculated by completing the square. Now, then you use Pythagoras to get CM. We use the Pythagoras to get AC. Yeah, AC. We use the Pythagoras to get AC. So AC squared plus MCM squared equals to AM squared. AM, remember, is our hypotenuse. Then you use Pythagoras. And the reason why you use Pythagoras, yes, it was not given that it's a right angle triangle, but you will say, you can also say, let's write this on the statement. We say triangle, you can say triangle ACM is a right angled triangle. It's a right angled is a right angled triangle. It's right angled. And then your reason will say radius perpendicular to tangent. Radius perpendicular to tan. You have to mark it because it was not given. So then you use Pythagoras. Then from there, when you substitute, you get the answer here as 4 root 2. It means the answer will be C in this case. 6.3, the numerical value of K is, if you want to know the numerical value of K, then you'll just say K lies on line AC, and we know the equation of AC, the tangent, which is y equals to x plus k. But because you know the coordinates of A, then you substitute A at AY is 0, at x is -7 because A lies on the tangent. Then K will be 7. 6.4, the equation of CM is. So first, we say the gradient CM is the radius. The equation of the gradient of the radius times the gradient of the tangent is -1. then because the gradient of tangent we know it as 1, then it means the gradient of the radius is minus 1. Remember, cm is the radius. Then you substitute the coordinates of the center because the center lies on cm. So y of the center is 2, x of the center is minus 1. Minus 1 of the x, that becomes minus 1 of the radius, is positive 1. When you take it to the other side, it will be negative, then c will be 1. Therefore, the equation of cm will be negative x plus 1. Last one, the coordinates of c. Remember, c is the point of intersection of the tangent, which equation is x plus 7. Then the equation of the radius is minus x plus 1. Remember, they intersect at c. So you solve them simultaneously using the 2 points. You equate them. Therefore, x plus 7 equals to minus x plus 1, which we calculated in 6.4. Then you solve them simultaneously. X will be negative 1. Then y will be 4. Then the coordinates of c will be minus 3 is to 4. Learners, that's the end of the mediation of the answers of the test written on the 6th of October 2010, analytical geometry. So please keep on going back to this. If when you check the answers you don't understand, then I try to explain everything here. Don't forget that the fight is not over. Fire all your cylinders. Follow your study timetable. As I said, make sure that you study all the subject every day so that when you write your final exam for any subject, you are not stressed with studying all the subjects at the same time or studying a subject just a day before that. If you want to finish the elephant, you must eat it every day. You can't eat it in one day, otherwise you'll have a problem. In this note, learners, thank you so much for watching. Please subscribe, and your commitment will definitely bear fruits. Thank you so much. Until we meet again.